This specimen is 0.4% carbon steel, again medium steel. However, this time it has been heat treated, a treatment referred to as annealing. It's been annealed in the furnaces in the lab. This process involves heating this steel to just over 950 degrees Celsius. Once at that temperature, it's maintained at that temperature for approximately an hour, and then the furnace is turned off, and the specimen is left in the furnace to cool down very slowly, usually overnight. That process of high temperature heating and very slow cooling is a type of a heat treatment referred to as annealing. This heat treatment is the only difference between this specimen and the previous one. The test will begin so as to compare the results. A reminder that the red line is the plot for 0.1% carbon steel cold drawn, and the dark red plot is that of 0.4% carbon steel cold drawn. The green plot is the heat treated specimen. It's already displaying a different plot to the cold worked specimen and will likely impact the properties of this metal. This plot has a lower maximum load, a lower yield point. In terms of comparing ductility, it's displaying a lot more in the annealed medium steel form. The colouring is different on the annealed steel because it's been oxidized in the furnace. The furnace used is not a vacuum furnace, hence the air oxidizes around it and forms this carbon layer. During the test, some of the carbon layer will flake off, but this does not affect the results being investigated. It is worth pointing out for all the specimens, the maximum point is not the point of fracture. There's always some kind of extension before it does eventually fracture, and this is a warning sign, indicating the component or product is going to fail, offering an opportunity to intervene for possible replacement or fixes. The load begins to drop, the specimen, like the others, will go towards failure and the machine will stop at fracture. Results for 0.4% carbon steel annealed. The maximum load, Fmax, is 7,479.87 newtons, and for the force at yield, Fy is 3,874.11 newtons.